Right. Yeah. So, right. Because of the that we have been fantastic, putting up makers, right? I did not know aware of which is probably James. Anyway, that's why we are reduced timetable so that I will not give you my lecture. I will only provide materials. So today we will have there's two lecture for your student and also one discussion or originally scheduled lesson, right? So let's start with the right.
Today's topic is subsea plant engineering and conventional field development procedures and production infrastructures like CPF and FPSO. First, I will introduce the field development procedures of the offshore production. The procedure is like shown at in the figure. First, the discovery and evaluation, and development and production and abandonment. And this lecture, I will focus on the production procedure. For example, this project is conducted in Australia for production LNG and LPG, and our Korean company are involved to this project, like Samsung Heavy Industry and Renewable for making the GPS and FPSO. And I will talk about the CPF and FPSO. The CPF means the Central Processing Facility, and the rule is electronic separation of oil and gas occur, and gas treatment and pressure stabilization and distribution and transmission. To achieve these rules for the CPF, it consists of the separator and compressor, and cruise tank and pipeline system. And for your better understanding of the CPF, I will show some videos about the modeling of the CPF.
An offshore oil rig or offshore platform is a large structure that is used to extract oil or natural gas in the rock beneath the seabed. In deep water up to 1700 feet, fixed platform will be used. The platform is held in place by large steel or concrete legs that attach to the ocean floor. From 1500 to 4900 feet, a taller fixed platform called a compliant tower will be used. For deep water, up to 12,000 feet, floating oil rigs will be used. There are several types of floating oil platform in use. In this video, we are using a semi-submersible platform as an example. This platform is supported on large pontoons. These pontoons provide buoyancy, allow the unit to float and be towed from location to location. Some oil rigs are also equipped with propellers under the pontoons. Anchors will be used to secure the rig in a designated spot. Once on the location, the pontoon structure is slowly flooded to keep them below the sea level. The workdecks float on top of the water, while the vast majority of their mass is below the water surface. Without the pontoons being submerged under the water, the platform will be unstable when the sea is rough. Let's take a look at what's on the oil rig. This is the hoisting system. It is used to raise and lower the drill string. There are cranes. They are used for transporting supplies between ship and the oil rig. Living quarters. This is where the crew members stay, eat, and sleep. Helicopter pad. Crew members will be transported using helicopter. Emergency lifeboats. An escape plan for crew member in case of any dangerous situation. These guys must be sent to push all the dirt and rocks out.
CPF, for the production of oil in offshore. And the next one is FPSO. It's similar to CPF, but it is made for moving structure, so it has more strength for the oil and gas, and it's for the one of these purposes off-roading and deep-water operations and flexibility and mobility. The shipcase rules, it is made of the hull and dispensing facilities and storage tanks and mooring system and off-roading systems. I will explain about the mooring system. Mooring system is in FPSO is allowing the vessel to rotate freely, so it can provide stability and flexibility in harsh offshore environment. And I will show you the videos about the FPSO. So, there's the mooring system and also the pipe for transport the oil and gases. And the mooring system provides the stability of the ship. So, and there's some processing parts of the engine and streaming parts here. First talking about the CPF and MPSO. The main differences of these both of them is uh, the application and mobility. CFP is fixed structure, and but the MPSO is mobile structure, so it can apply to CFP can be applied to establish speed pipelines, but the MPSO it can be applied to remote or exploratory deep water field. So thank you for listening, and we have a question.
So we need to have a more standing text. Probably have a one more. A bit more explanation on forest system. So the pipelines are fixed to the ground, right? They should be connected to the oil shell reservoir. So oil is flowing, or gas or oil is flowing through the riser system, as you see in the video. So that the pipeline should be fixed to the ground, right? Cannot move. But ship is rotating. So between the turret system and ship, the flow, the gas or oil should be flow. But one is moving, the other one is fixed. So there should be some special device inside. Right? That is the function of the turret. So the manufacturer of the turret system is very, how can I say, specialized, and sometimes the shipbuilders around the world waiting for their delivery. In Korean, they are calling super so suppliers has a strong power because they have a similarly to the gas tank or French company provide a data on gas tank or LNG system. So there are several such as specialty manufacturer. We have the technology and consumer. Okay. Next. Okay.
Okay, good afternoon, everyone. Today I'll talk about the ocean renewable energy. This is the contents. Contents as follows. So first we talk about the what is the renewable energy, and today I'll cover the three renewable energy sources. First one is wind, the second one is tidal energy, and third, the last one is the wave energy. First we have to know what is the renewable energy. So renewable energy refers to energy collected from the resources that are naturally replenished over time, such as the sunlight from the sun and wind, rain, tides in the earth, and waves on the oceans, and the geothermal heat also. So there are various types of renewable energy, but the majority, almost the 99.98%, originate from the sun. So wind is generated as air due to the solar energy in the earth, and the flow of the water reserved from the rainform, but the evaporation of the water vapor heated by the sunlight.
So the renewable energy systems encompass a wide range of the technologies and have become significantly diverse over time. So some technologies have already reached maturity and are economically competitive, and while others still require further developments. So this graph show the share of the renewable energy. So according to the graph, the solar and the wind account for over 80% of the share in the renewable energy. The blue one and the yellow one, the orange one. So these two technologies dominate the sector for the following reasons. The first reason is the abundant resources. The solar and the wind energy are abundantly distributed worldwide and making them easily accessible in most regions. And second reason is the technological advancement. So the advances in solar panel and the wind turbines technologies have significantly improved efficiency and reduced cost. And third reason is the economic viability. The continuous decline in the cost of solar and wind energy has made them more competitive compared to the conventional fossil oils and other renewable energy sources. The last reason is the versatility. The solar and the wind system can be utilized on the various scales from the small size to the large commercial projects. So next I'll talk about the wind energy. So as you guys can see in this graph, for thousands of years ago, the wind energy has been used in agriculture, such as the grinding the grains and the water pumping. And the wind power generation began in the late 19th century. So from the 1980s, technology matured and the large-scale development began in earnest. The start in 1980s, they made some wind turbines to power generations. So as you can see in this graph, the growth of the wind energy continues to progress, making it the leading renewable energy source in the terms of generation capacity. So this graph from the Global Wind Energy Council. So according to this graph, the cumulative installed capacity of the wind power generations reached approximately 906 gigawatt by 2022. So during the same period, the onshore wind turbine accounted about 842 gigawatts, representing approximately 93% of the total wind power generation. So among the countries, we can see that China in the first place, and the United Kingdom in the second place. So China's extensive land utilizations and the UK's abundant wind resources give them a significant advantages in the wind power production and the wind power generations. So before we discuss about the technologies about wind power generations, we need to know about wind formation and how to circulate in the earth. So wind is traded when the sun's radiation energy that hits the Earth's surface unevenly. It causes the pressure difference in the surface in the Earth. So then the air moves from the areas of high pressure to the low pressure, and it leads the atmospheric movement and the formation of the winds. So while winds are generated from various reasons in different regions, but the three primary circulation patterns form the foundations. So the three patterns is like this. First one is Hartley cell, second one is the barrel cell, the last one is the polar cell. So Hartley cell is the circulates air between the equator and the 30-degree latitude. The warm air rises at the equator and moves polarward to the north and cools and sinks down, driving trade winds and creating a desert at 30-degree latitude. And the second one is the paracel over here. The paracel lies between the 30 to 80-degree latitude and is driven to intersection with the neighboring cells, the hydrogen and the polar cells. And it generates westerly winds and influences temperature weather systems. And last one is the polar cell. The polar cell operates between 60-degree latitude and the poles, and holds dense air sink at the poles and moves equator ward to the down, and creating polar easterly winds. So next is the types of the wind turbine. There are various types of wind turbines. But the most common way to classify the wind turbines is based on the direction of the wind related to the turbine. So if the wind flows parallel to the turbine axis, it is classified as a HAWT, horizontal axis wind turbine. But conversely, if the wind flows vertically, it is classified as the VAWT, vertical axis wind turbine. The HAWTs are further categorized by the number of the blades, while the VAWT are classified by their shape. Like this one is the Darius type, and this is for the Sylvanus type. So since the WTs have the advantage of the scalability for the large-scale applications, they account for the majority of the wind turbines in today's use. So next up, offshore wind power generations. The wind power generation technology has been gradually shifting from the land to the offshore in recent years. Currently, over 90% of the wind turbines are located on the land, as I mentioned before. But research and the development technologies are increasingly focused on the offshore wind power. The main reason for the shift lies in the advantage of the offshore. The wind, such as having access to much stronger and more consistent wind resources compared to the land, and it caused significantly less impact on the local communities. The offshore wind power is broadly categorized into fixed bottoms and the floating systems, which are further divided into various types based on their design and structure. So as you can see, on the fixed types, there's a monopile, tripod, and the jacket styles. Uh, on the other hand, the floating styles, there are semi-submersible styles and cylindrical styles. So this is the evidence that why the offshore wind power is more better. The following graph allows us to understand the advantage of the offshore wind energy. This data includes the wind maps of South Korea on the left and the United Kingdom on the right, where the wind power technology is highly developed, as I mentioned before. As shown in the data, even near the coast area, the average wind speed that are twice as fast as those in the land. So the blue is almost 4 meters per second, and the orange and the red one is 8 meters per second. Same as this. So next is the pros and cons about the wind power generations compared by types. So about the onshore, they had a low cost and easy to maintain advantages, and negative impact and natural landscapes, limited space for the large scale project, disadvantages, and others like this. I'll give you guys the time to read it. Next, we'll move on to tidal energy. So the tidal energy is the method to generate electricity by using the tidal difference in the oceans to rotate the turbines. So the gravitational pull of the moon causes the Earth seawater levels to rise and fall, and which is harnessed from power generations. So it is essentially hydropower from the sea. During high tide, the water is stored in the reservoir, and during the low tide, when the opposite seawater level drops to create a head, the stored water is released to drive turbines and generate electricity. So make it easy, it's like a ocean-style hydropower generations. So there's three reasons for the tidal phenomena, tidal differences. First one is the moon gravity. The moon gravity pulls the Earth's seawater strongly, creating the high and low tides. The second reason is the sun's gravity. The sun's gravity combines with the moon's gravity to influence the magnitude of tide. So spring tide and neap tides depends on the relative position of the sun and the moon. Last one is the Earth's rotations. The Earth's rotation causes the seawater to move, leading to high and low tides occurring twice a day. So among this, the moon's gravity effect is more biggest. So I prepared some video of the reason of the tidal differences. It's not working, so just a 20-second video. I upload it on the console later. So this is the types of tidal power generations. There's a big two types. The first one is the single flow, and second one is the double flow. The single flow is divided into two. The first one is the fluid flow type, and the second one is the air flow type. The fluid flow type is utilize the water level difference between sea and the reservoir during the high tide to generate the electricity and discharge the water from the reservoir to the sea at the low tide. The air flow type is stored water in the reservoir during the high tide, and they fluid it down to the oceans when the low tide. The next one is the double flow. It's a little bit different. They generated electricity by utilizing the water level differences between both high tide and the low tide. It's the double wave. This is the types of generator, but the tidal power generations. The left one is the ball type turbine, and middle one is the strap flow type turbine, and last one is the cupola type turbine. So there's a different meaning of that. First, the ball type is a turbine, and generators are arranged horizontally inside the bulb-shaped casing. This is the bulb-shaped casing, and the turbine and the second one, the strap flow type. The generator is connected outside the turbine and rotating around the central axis. Its simple structure ensures easy maintenance and effectiveness in the low wet conditions. And last one is the tubular style turbine. The features are horizontal shaft aligned with the water flow, like this, and allowing smooth water passage, and commonly used in low head, high flow scenarios of maximum efficiency. So among this, the verb type is the most common one in the tidal power generations. So last one is the wave energy. So we need to know about what is the wave energy. So the definition of wave energy generations is like this. The wave energy generation is a renewable energy technology that convert the energy of the ocean waves into electricity. So the principle of the working is the waves move up and down or forward and backward. This kinetic energy in these waves transferred to the generator to produce the electricity. The key method of the wave power generations is the wave energy generation uses the various technologies such as the air compression systems or floating system and pendulum and the motion system. So last is there's advantages. The waves are a continuous energy source in the earth and they enable to stable power generations. So as I mentioned before, about the wave energy, there's a different and lots of types of generating styles. The first one is the point absorber, as you can see. So this is point absorber. Point absorber are floating devices anchored under the seabed, and they move up and down with the wave motion. And they use this kinetic energy to drive a generator. So their compact design allows the deployment in various marine environments. So the second one is the oscillating water column. So this is the turbine, and this is the landscape, and this is the ocean. So this system uses the wave motion to push the air through a turbine. So when the wave comes here, the air is coming up, the waves go to the left, and the air goes down. So as weight rise and fall in the chamber, they compress and decompress the air in the chamber, and they drive the generator to make the electricity. And the third one is the attenuator. The attenuator is a long and segmented floating device aligned with the wave directions. It flexes with the waves up and down motions, converting mechanical movements into electrical energy. So its modular design can be scaled up, easy to scale up, and more easy to make larger and longer. And the fourth one is the uh, wave overtopping reservoir. So there's a reservoir on the top, the floating device in the oceans. The system captures the wave energy by allowing wave to flow into the raised reservoir over airs, and water is then released back into the sea through there, and they generate the turbine through here and make the electricity. So it is particularly effective in areas with a strong and consistent wave activity. And this is the last one. This is the inverted pendulum. So as you can see, when the waves move, pedal with the pendulum is moved left and right, and the the motion activates the hydraulic pump over here, and which powers the generator to produce the electricity on the onshore area. So with the simple design and mechanism allows for the low maintenance and the long-term operations. Okay, this is all for my speech. If you guys any questions, thank you.
Questions? Right? So, one thing you have to think about in terms of renewable energy is energy density. You can find out more. Video something. The basic unit is joule per cubic meter. So wind or wave or tide, they may have their potential energy inside. We call this is energy density. Comparing to the, say, traditional fuel, it's like gasoline, oil, the density level is much lower here. So there is a problem, difficulty to get economical renewable energy because the density is very low. So you need to be late 300 or 100 meters to get 1 megawatt of power. You have 200 times. Big ones, so capital cost is higher. Also, to rotate this big one, you need to have a high wind, strong wind. Otherwise, it does not move. So you need to find out good place. There is nothing. There is. Okay. So let's go on to discussion.
started.
화면을 전체적으로 룸에서 보면
Today's discussion is about substance engineering. So there are two main goals for this discussion. First, is the advantage of contentious FPSO, and second one is pros and cons of submarine. As explained by the earlier presentation today, FPSO is a floating vessel that is used in the offshore oil and gas industry, processing and storage of hydrocarbon wells under can be fluid. It receives hydrocarbons from itself, nearby platforms, or subsea outlets. It stores oil until it is offloaded in a tanker or transported through a pipe. FPSOs are either converted from oil tankers or custom designed and built specifically for them. Also, I'm surprised that Chair Cindy here is fine. As he explained it earlier in this video, today's first discussion is about the advantage of our contact vessel. So, if you guys have any ideas, please feel free to and move the oil off the speed. But the CDPF is the stop one, is the big effect. Well, it's small, so there's its own motion systems and can free the receipts. It might be advantageous, in a way he explained. It can, you know, transport the resource by itself. However, most of the cases, the resources are transported by other vessels. First, also two. Yes. Right. Is ideal for the frontier offshore regions where there's no infrastructure such as local pipelines, and it is rapidly deployable in months, and it's an advantage compared to other means such as semi-submersible rigs and jet rigs, which would take about up to 4 years for it to functional. Heavy move through, and therefore can cover more marginal field. And since it can move to other seas, it is suitable for areas where they're experiencing demanding weather conditions like storm. And it can be economically advantageous because it can be converted from an oil tanker, and it is environmentally friendly because it leaves minimum ecological footprints, unlike other means. Next one is about submarine cables. And these submarine cables are laid on the seabed between land-based station, carry telecommunication signal across oceans and sea. And those submarine cables were laid in a team to carry telegraph traffics. However, these days is used to carry telephone traffics and digital data communications. I'm going to show you a video about these.
Severing two communication cable lines between NATO allies and peace. A Chinese vessel has also been implicated in the incident. Danish authorities detained it on Wednesday. The cuts happened earlier this week to the sea lion boarding cable connecting Poland and Germany, and a 130-mile line connecting Sweden and Lithuania. Investigators are probing cable events of a Chinese bulk carrier that traveled to Egypt and Russian ports. Due to data tracking, the ship passed close to both telecommunication cables the suffers Monday. The Danish Navy mutually detained it. It says that the ship damaged the cables with no further comments. Social media reports have claimed the ship had a Russian captain. The assertions have yet to be independently verified. A separate Chinese registered ship reported to cut the Baltic Connect pipeline last year, and a telecommunications cable connected Finland and Estonia with its England. Officials familiar with the investigation say Russian sailors were on that vessel at the time.
Basically, a cargo vessel, the European underwater cables. So, I heard that they use their anchors, and they kept their anchors down when they cruised. So that's how they damaged. So for the next topic we would like to discuss is the pros and cons of solar hurricane. So if you have ideas on these, please tell us too. Feel free to help.
Countries and work together. That's okay.
Or that's most important part of the submarine cables. They do connect the between the continents in extremely high speed and reliability.
Since buys
So in a video previously, when it's damaged, it would be extremely hard to repair because as you mentioned, it lies very deep underwater where there's so much pressure.
natural cooling because it's smaller and pumps not only human but sea animals can damage it, especially like ships. So people
Calling, since it's a magnetic-based communication, usually needs relay circuit to use. So it might be helpful to have natural cooling event. So installing the cables are an extremely expensive and tedious process. It's also dangerous.
ranking goals. Not a lot of so I think it's more safe than so big goals of team for the losing.
Like most of the backbone cables course the majority of it is consists of fiber optics and therefore it's analog, so it is hard to spot it all. So yeah, I think we got almost everything covered here. First, it offers high communication bandwidth and low latency, and it is reliable because it's immune to electromagnetic interference. And it is comparably cost-effective to other means such as satellite communications, and it is non-polluting and non-lasting. And it is said that these cables last for 25 years, and most of them are replaced before their lifetime expires. And it is vulnerable to disasters such as mudslide, submarine earthquake, and such uh, incidents like the we saw in the video previously. And it is not suitable for remote village and terrains, and especially islands where few people live. And installation process is expensive, and when it is damaged, it can require immense time and cost to repair. And that's all for this point. If you have any questions about this topic, please feel free to ask me.
Yes, for today. And on Thursday, we will have a one lecture and two discussion. Okay? Right. Yeah, Thursday. And next week, we will have a special class. All right, see you.